So we're looking today at the second part of our lesson about permutations and combinations. So yesterday we talked about the idea of permutations where order is important. So when we're looking at permutations, we're looking at arranging some type of order: first place, second place, third place, a president, vice president, or secretary. Now, today we're going to talk about the idea of combinations. Now, combinations are where order does not matter. We are just mixing things up and we're trying to find how many ways we can get things to work together. Does not matter about the order that we choose for them. So for that reason, you're going to see a separate divider out of your formula. So for an example, if we have a fruit salad, it doesn't matter what order we put the fruit in. We're mixing it all together to maintain one fruit salad. So a combination formula is going to look just like our permutation formula, where we're going to take n factorial, the total number of objects, and divide it by the positions, n minus r factorial. But you're going to see this extra divisor down here where we are dividing out our repetition. So this kind of combines the idea of permutations and permutations with repetition. So what we do is we divide out an extra factorial to take out any repetition that we will have. All right, so let's look at our first example with combinations. So it says 5 cousins at a family reunion decide that 3 of them will go to pick up pizza. How many ways can they choose 3 people to go? So they're just choosing a group of people. So for this reason, the order that they choose those people are not going to matter. So this is going to be a combination. So this is a combination of 5 cousins, and we want to choose 3 people to go pick up the pizza. So our n is 5, and our number of choices, which will be r, is going to be 3. So our calculation would be 5 factorial divided by 5 minus 3 factorial divided by that 3 factorial. Now, again, that's going to divide out of there so we can get rid of all of the duplicates. So to simplify this out, we have 5 factorial divided by 2 factorial divided by 3 factorial. Or I can simplify again. I'm going to cancel out these 3's and have 5 times 4 divided by 2 times 1, which is simply 10 ways we can pick out of the 5 cousins, 3 of them to go. Now, if this were a permutation, this number would be much bigger because we didn't have that extra number being divided out. All right, let's look at another example. 6 friends at a party decide that 3 of them will go pick up a movie. So same idea, so just practicing with our combination problem. How many ways can they choose 3 people to go? Again, the order doesn't matter, so this is a combination, and we are picking out of 6 people, 3 of them to go. So we're going to have 6 factorial. 6 minus 3 will be 3 factorial, and divide that by 3 factorial. Or if you found that NCR button in your calculator, you can utilize that button now. But what you have to do is you have to put in the total number first. So you'll put 6, and then you'll go into that probability button and hit NCR, and then you'll hit 3, and it will do all of that work for you. But if you understand the formula, you'll understand why you have to take that extra divisor out. All right, so let's look at a third problem. This one is 6 cards are drawn from a standard deck of cards. How many hands consist of 2 hearts and 4 spades? Okay, so now we're looking at a multi-layer problem. When you see words such as and or. So in math, we always understand that if you see or, that should mean to add the math together. If you see and, that's going to mean to multiply. This and that is going to mean to multiply. So this is what we have. How many hands consist of 2 hearts and 4 spades? 2 hearts and 4 spades. All right, so to calculate this, we need to first know how many total hearts and spades are in a deck of cards. So if you know anything about a deck of cards consists of clubs, spades, hearts, and diamonds. Altogether, there are 4 suits, so those are our 4 suits, and there are 13 cards of each suit. So there's 52 cards in a standard deck of cards. So that means I have 2 hearts to choose from out of 13, and I have 4 hearts to choose from out of 13 spades. So that means I'm going to have, and it doesn't matter the order that I choose, so that means I'm going to have a combination of 13 hearts, and I want to choose 2 of those, and the combination of 13 spades, and I want to choose 4 of those. So we'll do those calculations, and again, you can use your combination button in the calculator to understand, or if I could do the quick work of the math, that'll be 13 factorial divided by 11 factorial, and I'm going to divide out the overlap, times 13 factorial divided by 13 minus 4 is 9 factorial, divided by 4 factorial. If you're doing it in your calculator in this way, you probably want to put a set of parentheses around the denominator just to make sure those are being multiplied. All right, so we have 13 factorial, or 13 combinations of 2, and that's going to give me 78 times 13 combinations of 4 will give me 715 for a total of 55,000. I thought I was looking at the wrong number. 55,770 ways you can choose 2 hearts and 4 spades in a standard deck of cards. All right, we're going to do one last example, and this says 13 cards are going to be drawn from a standard deck. How many hands consist of 6 hearts and 7 diamonds? Okay, so again, there are 13 hearts to choose from, so this is going to be the combination of 13, and we're going to choose 6 of them, times the combination of 13 diamonds, and we want to choose 7 of those. So the math is going to be 13 factorial divided by 7 divided by 6 factorial times 13 factorial divided by, look at this one, 13 minus 7 is 6, and our overlap would be 7. So if you look at the work for these two, the math is exactly the same. So I'm going to get 1,716 for 13 combinations of 6, and I'll also get 1,716 for 13 combinations of 7, and there will be 2,944,656 ways I can choose those cards. Okay, so now what you're going to do is you're going to look at some problems today that's going to mix some of the permutation and combination ideas together. So make sure you identify first if the order is going to matter, and then decide if you're going to need a permutation or a combination. All right, if you have any questions, just let me know. I hope you all have a great day.